So let's think about how we see colours in a bit more detail then. I have this sheet of white paper here. Now the white paper looks white to you because it's actually reflecting all the different wavelengths of light. So it's reflecting blue light, red light and green light. So it's activating all the cone cells on the back of your eye, and so you perceive this as white. With a black background, on the other hand, this reflects very little light. It tends to absorb the light, and so it's not sending red, green or blue light towards the cones in the back of your eyes. So you see this as a lack of colour, and your brain interprets that as black. This green leaf absorbs the red and blue light and reflects the green light. And so your eye perceives this leaf as green. So this means that the green light is actually the relatively useless light for the leaf. If you tried growing green-leafed plants under green lights, they wouldn't grow very well because they wouldn't be getting enough energy to photosynthesize. Similarly, my shirt appears red to you because it's reflecting red light, and so it's stimulating the red cones on the back of your retina. So now we all learnt about mixing colours back in kindergarten. We saw that if we mixed yellow and blue paint, we got green. So this is because yellow paint reflects yellow light, blue paint reflects blue light, and so when we combine them together, we just get reflected that bit in the middle, which they overlap at green, and so we perceive this as green light. Similarly, red and yellow give us orange, blue and red give us purple. And did you notice when you were in kindergarten, when you tried to make purple, it always looked a lot darker than the other colours? That's because blue and red have very different wavelengths, and so there's much less overlap between them, and so we tend to get a much darker colour as there's a lot less reflected light when we mix those two together. Now when we mix lights, we actually get very different combinations of colours. So when we talk about primary colours for mixing light, we're actually talking about red, blue and green. So it's red, blue and green because our eyes have cones which detect red, blue and green light. So in kindergarten you learnt that it was red, blue and yellow. Now it's red, blue and green. When we add light colours, we're actually stimulating more cones rather than reducing the amount of reflected light, and so they add differently. When we add red and green light, we actually get yellow light. So you can look at this picture here where we've got the three light colours coming in and being reflected, and you can see where red and green meet, it actually looks yellow. Where blue and green meet, we get a colour called cyan, which looks a bit like aqua blue. And where blue and red meet, we get what's called magenta, which is kind of a pinky purpley colour. So when you go and buy inks for your printer, you can get yellow, cyan and magenta, and these three colours add together to give you all the colours when you print. So if you want to know more details about adding colours with light or with, in the reflective case, with paints, you can have a look at Jo on PhysClips. I've put the link just below this video.